Yeah. So in this demonstration, we'll be talking about Python classes. Okay. How do we write methods inside classes? Okay. When I say methods, it includes, the init method, which is used for, initialization of a particular object. So the various attributes of a class, how they can be initialized. Okay. And how we can, create objects using these classes. Okay, so all these things we'll be practically doing with the help of a class called arithmetics. Okay, so my class name will be arithmetics. Then we will write various methods inside which, and we'll be writing a lot of classes, a lot of methods called str. Okay, which is a string method which brings out the data inside a class in a string format. Okay, so all these things will be practically doing it. Okay, so let me go to my uh, Jupyter notebook. So let us start with a class arithmetic. Right? So when I say arithmetic, I give a colon and I just say pass. Okay, I just give enter. So there is no error. That means a class has been created. Now what I'll do, I'll just start writing the init method. So when I say init method, def underscore init underscore, then I'll say self refers to the invoking object, comma. So in arithmetic, what are the different parameters I want to initialize? So let us call I want to initialize a parameter called factorial, or whatever it is, factorial. Or I can just say, instead of factorial, I can just give a variable called num. So on num only we're going to apply various operations num. Okay, so this is the num parameter. Then what I'll do, I'll just say self dot num is equal to num. Okay, so this num I can make it private, so that I just double underscore num. Right. So what happens is, so I've created a init method, okay, and which takes num as parameter, and I can make this num as a default value. I can make it 0, so that even if I don't pass any values, 0 will be taken automatically. So I'll just say def underscore str underscore self, which returns okay a string format, raw string format of the num is equal to, I'll just say num. Okay, num self dot num. Okay, so what does it mean? See, I'll just create an object of this particular class. Let us call AR1 is equal to arithmetic. Okay, arithmetics. And in fact, arithmetic it is. Now, if I just say print AR1, okay, so there is an error over here. Let us see what is the error. Arithmetic of this no attribute num. Okay, so it should be underscore num. It should be underscore num. So I can see here. See what happens is, I'll just explain here. Now this init method, okay, takes two arguments. One is self. Self refers to the object which is on the left side, or object which is used for invoking the methods of the class. Okay, fine. Okay, now this num refers to the parameter which we are passing. When I don't pass any parameter here, by default it takes 0. So that's called default value. So num is set a default value of 0 if you don't pass any parameter. Suppose if I say 10, then look at this, num will be 10. Now how I am able to print num is equal to 10? Suppose if this method is not there, I won't get it. I'll just comment it out and I run it. See, I'm just getting main arithmetic object, something like that. Okay, only if I have that underscore str method, look at this, underscore str then self. Basically, this method brings out the string representation of an object's attributes. Okay, when I say an object attribute, here AR1 refers to an arithmetic object. Okay, now this AR1 contains an attribute called num, underscore num, which is a private attribute. Now that private attribute can be given a string representation, string output. Okay, that's what it does. Say return raw format of num is equal to, see this num can be anything, number is equal to, it doesn't matter, but this you cannot change, this you cannot change. It should be self dot underscore underscore num, because that is how the variable has been created. Okay, now look at this. See, number is equal to 10, number is equal to 10, fine. So this is how you create an object of that particular class, and then you're able to print the string representation of the attributes. Okay, so for example, if I have more than one attribute, okay, for example, you see num square. Okay, now of course num is basically can be squared, something like this. This is self dot underscore underscore num square is equal to, okay, I'll just say self dot underscore underscore num into self, okay, dot underscore underscore num. Okay, so num square will be, look at this, num square square, okay, square, okay, it doesn't matter, square is equal to, I'll just say self dot underscore underscore num sqr. Look at this, I'll get 100. Okay, so you can have any number of attributes like this, and you can just bring out the string representation of all the attributes using underscore underscore str method. Right? Okay, now this is a method, okay, which is, basically it's coming from the base class. Actually, you're overriding the method which is at the base class. Okay, now I want to add some specificity to this particular class. When I say specificity to this particular class, I want to add speciality. Okay, arithmetic, I give a name. Okay, I want to get the factorial of this particular number, so I'll just say f factor. Okay, that's a method. Self, that's it. Okay, now this factor method will bring me the factorial of the underscore underscore num parameter. Right? So how do you get the factorial? So when you say factorial, the number should be multiplied by, okay, the number up to 1. So what I can just say for I, okay, in range, I can just say starting from number, I can go backwards also. Starting from, I can just say self dot underscore underscore num comma step, okay, I can just say -1, or I can just say, okay, what I'll just go from here, starting from 2 to, okay, self num +1, I'll just +1, I'll just, okay. So that means what, for I in range starting from 2, suppose if I see I given underscore underscore num as, okay, 5, I want 5 factorial, I want 5 factorial. So what this method can do, thus this method can do for I in range of 2 to, okay, so self dot num +1, num +1 means 5 + 1 6, so it can start from 2, go from 2 to 6. What it can do, I'll just say f is equal to 1, then I'll say f is equal to f into I, return f, return it. Okay, now, so this factor method, okay, which starts with f is equal to 1, and then we multiply number right from 2 up to that number in num. Suppose if I had given num as 5, 2 to 5 will be multiplied, so I'll get 5 factorial, and it will be returned. So what I can do, I can just go here, I'll just say print ar1 dot factor. That's it, factor. Okay, now look at this, 120 I got. 120 is the factorial of 5. Suppose if I say 6, I'll get 720. Look at this, I'll get 720. If I give 4, I'll get 24. So you can just see here, now this this particular method, it brings the factorial of the given number, but it does not maintain the number which is returned. So if you want, you can do this way. See, so that you can just say self dot underscore underscore factor is equal to f, so that that result will be stored in factor. So I can fetch it from somewhere here. Look at this, I can just say factorial is, okay, self dot, okay, underscore underscore factor. Okay, fine. So now look at this, I'll just say Control C, Control V. Okay, I will just comment it out. So automatically you get 4 factorial. Look at this in string function. So I think some problem, we'll just see. Print ar1, oh, factor. So what is the problem? We'll see. self dot underscore underscore factor. Okay, I'll just say factorial. Factorial. I think we should get it. We'll just see what happens. So let me see what happens. Yeah, I'm calling arithmetic. I have not called factor at all. I have not called factor at all. So I should call it. Okay, fine. Now I'll just see. I'll just show you the output. Okay, arithmetic just now attribute arithmetic factorial. Okay, so let me just see. Self dot factorial is equal to f. Return f. Okay. Self dot underscore factorial. Facto RAAL I given. Factorial I given RAAL only. Okay, let us see what happens. Okay, some problem here. We'll see. Okay, whenever you solve problem, you just always say, f. Okay, let me call f. That's enough. Okay, so let us see what happens. Arithmetic f is not there, it says. So let us see what happens. So self dot underscore f is equal to f is assigned to that. Then print self dot. Okay. Yeah. So I'm trying to print before only. So just comment it out. I think now we'll get it. After calculation, we'll get that value. Look at now we'll get it. Look at this. Num square is 16. Factorial is 24. So what the problem was? I am giving the print before. Okay, the calculation is called. See, factor is getting called here only. But before that only, I'm just trying to type AR1. So AR1 is just checking for self underscore f. So to avoid that, now what you can do this way. You can do this. Self dot underscore f is equal to 0. Okay, 0. So that way we can avoid that error. Okay, so now there will be no error at all. Look at this. Yeah. So I see factorial was 0 initially, then 24. Okay, then we got factorial is 24. So if I say 5 here, I'll remove this. You can see 120. Factorial is 120. So you can see now I'll just this method now. This method returns the factorial of the num parameter underscore num parameter. So how does it calculate? It starts from 2. It goes up to that num, multiplies each number by the next number, successive numbers. The result is stored in f variable. F is a local variable and which is assigned to the object variable. That means the attribute self dot underscore f will be maybe 120 or 24, whatever it is. I can just remove it. Then we return it. Of course, we return it here. We return it here. And then, of course, if you don't want to return that, what you can do, you can just set it there. You can just set it there and you remove this print statement. That's it. Okay, fine. Now it will be calculating the factorial, but it won't, immediately return the result. Look at this. We got it. Perfect. See, we calculate the factorial, but the result is printed using this particular statement. Look at this. Factorial is self dot underscore f. Where self dot underscore f is set the factorial value inside this factor method. Look at this. It's here. It's here. Okay. So we calculate the factorial, put the result in self dot underscore f. Then we are printing it using str method. That's it. Okay. So look at this. Now this is how you write a class. Okay, with the private attribute called num. Okay, which is set a value, and of course you can just you can write one more method where the method finds whether the number num is a prime number or not. So I'll write one more method here. Look at this. F prime or not. Prime not. I'll just say prime not. Self. We are not passing any parameter. Every method is applied on num attribute. Num is the attribute basically which belongs to one object. In this case, AR1. AR1 refers to one object. Right? Now, prime or not. How do you check whether the number is prime or not? If the number is divisible between 2 and the one number before that. So for that, what we can do, you can just say end is equal to math dot square root of, okay, self dot underscore num. Okay, fine. I'll just say print end, and I think I just import math here. I think math dot, okay, it is available here. We'll just see. I'll try to call. For time being, I'll just comment it out. Okay, and just say AR1 dot prime or not. Okay, so some error we get. We'll see what is the error. Math is not defined. So I'll just say import dot math, escape A. Yeah, math it imported. So math dot square root, I think now it should be available. Let us see. Yeah, we got, the square root of num. Num is nothing but 5. Square root of 5 is 2.23. This, what you can do, you can make it floor. So what you can do, math dot floor. Okay, now you see, you get 2. Okay, so fine. So see, the shortest method of finding whether number is prime or not is start dividing the number right from 2. That number, whatever number, maybe you want to find 17 is prime or not. Start dividing, okay, from 2 up to square root of 17. See, if I say square root of 17, I'll just see. See, 4 is the square root. So you don't need to go up to 16. Okay, you just go up to 2 to 4. If 2 to 4, if no number is dividing 17, then 17 is a prime number. That's it. Okay. So what I'll do, I'll just take this end. Then I'll just say for I in range 2, go up to end plus 1. So end plus 1 means go up to 2 to 4 inclusive. You have to go up to 2 and 4 also. So that I'm giving 5. I'm giving. Okay, so end is 4. So I'm giving, suppose in this case, if I give 17, I'll get the square root of 17 is 4. So it should be 2 to 4. So I'm giving for I in range 2 to 5. I am giving, so that it goes from 2 to 4. Now what I'll do, if self dot underscore num is divisible by, so when I say divisible, it's mod I is equal to 0. If it's equal to 0, okay, you can just say print, okay, print, I can just say this way, print number is not, see, self dot underscore num is not prime, and immediately you can break, or you can return from the function. Okay, otherwise what you do, if it comes to, if it successfully completes I, you can just say else print, okay, self dot underscore num, okay, is not a prime. Okay, not a prime number. Okay, so I just see, I'll just execute, show you output, then I'll explain to you. Look at this, let us see what happens. 70 is not a prime number. Sorry, if it is divisible, okay, then it's not prime. Sorry, otherwise it's a prime. I gave a wrong message, that's all. See, run it. 17 is a prime number. Okay, if I give, okay, look at this, 18 is not prime. If I give, 23 is a prime number. You can just see the output at the bottom. Okay, now what happens is, look at this. See, we take the number and we find the square root. Suppose if the input is 17, if num is 17, underscore num is 17, then it takes square root of 17, which is 4. So math.floor will get the integer which is smaller than the square root value. So it will be 2.23 square root value. The floor value will be 2. Then start dividing, okay, this num from 2 up to 4. End means 2. Sorry, end is 4. 4 plus 1, 5. So we start dividing by, okay, the 17 by 2. 17 mod 2, is it 0? No. Okay. Then okay, I goes to 3. 17 mod 3 is 0, no. Then 4. 17 mod 4 is 4 is equal to 0, no. Okay, none of these numbers divide 17. Then I goes to 5, but it's already over. It goes only up to 2 to 4. Immediately it comes to else part, then it says that number is prime number. Look at this. I just run it again. Okay, 23 is a prime number. I'll just say 231 is not a prime number. Some number divides it. So if you want to find out which number divides it, you can just go here and give a message. Look at this. Not a prime. Okay, because of I'll just show you which number makes that number not prime because of I. That's it. Now look at this. Let us see. 231 is why it's not prime because of which number? Because of 3. 3 divides 231. Okay, fine. Suppose if I say, okay, 29 should be prime, is a prime number. I'll just say 31 is a prime. Okay, I'll just make 257 is a prime number. I'll just say 258. Not prime because of 2, because 2 divides it. Okay, so this is how you write a class, a arithmetic class, give some private data, applies various methods, factorial, prime or not, everything can be applied on a particular data, and then you can bring out the result. Okay, so this is called object oriented programming in Python, where all the logics which we apply in normal Python can also be applied inside a class. Okay, hope this session was useful. We'll meet in some other interesting session. Thank you.